Hello dear programmers, how are you? Today we will solve another problem number 31, next permutation. It's of medium level and we are given a list of numbers, integer numbers like this one, and it requires from us to find the next permutation in lexicographically order. So let's forget about these names like this one and this one. Let me explain to you what they want from us here. So we are given this number, okay? This number have it's of three numbers, so it have six combination. Okay, it's 3 factorial. If it's 4, it will be 4 factorial. It will be like 24 combination. Okay, so next permutation or lexicographically order is like we think of it like it's one number. It's like 123. Think of it like one number, and every time the next number will be greater than the previous one, but it will be the next greater. So we cannot put this here. True, this one is greater than this one, but there's a combination that is smaller than this one, and at the same time is greater than this one. Okay, so it goes high bit by bit. Yeah, it goes high bit by bit. So next greater, not too much greater. So for 1, 2, 3, the next greater it will be 1, 3, 2, and then 2, 1, 3, and then 2, 3, 1, and 3, 1, 2, and 3, 2, 1. So next permutation, it's next smallest greater number than the previous one. Okay, so I cannot think of brute force way to solve it actually. So I will give you directly the correct solution, how to approach this problem and how to solve it. So given this one, okay, is of 6 digits. What's the next number after this one? So the pattern that I found that's very easy to implement, and it's like O of n complexity. It's like we check two numbers 2 by 2, 2 by 2, 2 by 2 like this, 2 by 2 like this, from right side, from the end of the array. If this number is greater than this, we find an index, let's call it I. And to solve this problem, I need two index, I and j. So 2 is less than 3, so it's not this one. So we come here. 3 is less than 5, so it's not this one. We come here. 5 is less than 6, it's not this one, so we come here. So 6 is greater than 4. And to be able to have, if you think about it, to be able to have a number greater than this one, we need to swap something with a greater number. So if we swap 3 with 2, we will get a smaller number. If we swap 5 with 3 or with 2, we will get a smaller number. So we need something greater than the one on the left of it to swap it to get a greater number. So we find the index I here. This number need to be swapped. Okay, yeah, but here the problem is we can swap it with 6. Also we can swap it with 5. And if you notice, here numbers are in decreasing order, and it's always after I, it will looks like it's decreasing order. Anyway, so do we swap it with 5 or do we swap it with 6? So in our definition, we want to find a greater number, but it's next greater, not too much greater. Swap it with 6, it will be too much greater because we can swap it with 5. 5 here is less than 6, so we don't need 6, we need 5. But how do we find it? We don't do like this actually. We don't like thinking and look at it and think. We need to do it programmatically, coding. So we find I, now we try to find j. And to find j, we take it from rightmost. Is this one bigger than 4? No. Is this one bigger than 4? No. Is this one bigger than 4? Yes, this is bigger. So this is our j. This is our j. So we have I and we have j. So next step, what we do, we swap. We swap 4 with 5 with 4. So we put 5 here and we put 4 here. Okay, now it's greater. This one is greater than this one. Correct? Yeah, because it's like 165,000 and something. Here is 164,000 and something. But is this one the next greater after this one? No, because here it's too much. It's too much. We can do better. So in my algorithm, in what's left here on the right of this I index is this number. We try to get the smallest of this, and it's, as you see, it's decreasing. It's decreasing. So we reverse it. We just reverse the remaining. So first we find I, then we find J, we swap I with J and reverse the left. So we will have something like this. This one actually is the next permutation of this number. It's the smallest number that it is bigger than this number, using all the numbers in the list. Okay, now I explain it. Let's go to the Jupyter Lab and implement our code. So first I will write a helper function at the reverse function, and it's just reversing. It's easy. So as we have left and we have right index, we just swap left with the right, it will be reversed. So while L smaller than R, so we say nums of L comma nums of R equal nums of R comma nums of L, and I make here a mistake. I should put S here. Okay, and of course we need to increase the left pointer and decrease the right pointer. That's it. That's the reverse function. And here we define I as length of nums minus 2. Why minus 2? Because we start with index, so it goes to the length of nums minus 1, and we need to check it with the next to it. So we start with minus 2. Anyway, now we say while I is bigger or equal to 0, so we did not go outbound of our array, and nums of I bigger or equal to the nums of I plus 1. And here if nums of I plus 1 is less or equal to nums of I, so we continue. We say, I have to put, yeah, we continue. We say I minus equal 1. We change the index till we find nums of I plus 1, which is on the right side, is bigger than nums of I, which is on the left side. When this one is bigger than this one, so we find our I index, and the while loop will stop working, and we have I value, correct value. Okay, so now what we do, we try to find J, and J we will start with length of nums minus 1, and we say if I is bigger or equal to 0, so we are good. Because if I is minus 1, for example, that's mean there is no bigger. So that means we reach to the end of the permutation, and it will rotate back to the start. So anyway, if you are good, so we say while nums of J less or equal to nums of I, then we update J till we find the proper J value. And when this num of J is bigger than nums of I, that's the J value that we want, and we find I and we find J. And now after we find I and we find J, as I mentioned, we swap it. We swap I, the value in I index, with the value in the J index. So it will be nums J comma nums I. We swap it. And what we do to the right of the I, we reverse it. So we reverse to the right of I, so I plus 1, to the length of nums to the end, minus 1. And this should be it. So let me copy this code and we go to the Leetcode website and test it there. So I pasted the code here. Let's click submit, and hopefully there's no error. Yeah, 100% time complexity better than others, and 86% space complexity better than others. So this is a great solution. Thank you very much for watching, and I'll see you in the next video.